Hi, my name is Matt Kustra, and I'm a fifth-year PhD student at UC Santa Cruz. My dissertation is focused on the evolutionary consequences of cryptic female choice. When we typically think of sexual selection, we think of traits that attract mates, such as the beautiful display of the peacock. However, in many species, females mate with more than one male, so sexual selection can also occur after mating. Cryptic female choice is when females can actually bias which sperm fertilize their eggs. So for example, here, females are biasing paternity towards the green male. And this is a relatively new and unexplored field, in part due to historic and current focus on male-mediated processes. And so we really have a lot of work to help better understand cryptic female choice. And despite being relatively understudied, we do have evidence that this is occurring in many species, from fruit flies to even some recent evidence in humans. Part of my dissertation is seeing if and how cryptic female choice can influence the evolution of male behaviors. And to do this, I use the Mediterranean fish species, the ocellated wrasse. The ocellated wrasse is an interesting species because it has three different male morphs. There's a large and colorful nesting male that makes a nest, and females heavily prefer to mate with nesting males. Then we have sneakers that dart in when a nesting male and female are mating and try to fertilize eggs. Sneakers are much smaller and of lower quality, and females try to avoid them. Then we have a third type of male called a satellite, and he pairs up with the nesting male, chases away sneakers, courts females, but also sneaks in. And when females lay their eggs, they're coated with a substance called ovarian fluid. The previous work by my advisor shows that ovarian fluid increases the relative importance of sperm velocity, which actually favors the nesting male since these males produce higher quality sperm. Because velocity has a time component, I'm interested in how ovarian fluid can influence the importance of the relative timing of mating. And to do this, we do field work at a marine station in Calvi, Corsica. We go underwater, we observe fish, and record videos like this one to understand the timing of the mating patterns. So far, we have found that satellite males sneak faster than pure sneakers, and that sneakers do better under busier social environments. To link these time delays back to cryptic female choice, I am currently conducting experiments in the lab to test how such delays interacts with ovarian fluid. My other half of my dissertation is focused on developing mathematical models to understand the long-term evolutionary consequences of cryptic female choice. And sperm are actually the most diverse cell. And pictured here are just a few sperm from different species to give a sense of how diverse their morphology can be. One hypothesis is that this diversity could be generated from cryptic female choice, but this has not been tested. So currently I'm developing mathematical models to test this. So far, we have found that cryptic female choice can generate variation across populations, and my future work is to see if these divergences actually can result in the creation of new species via reproductive isolation. Thank you for ARCS for funding me and providing me for the opportunity to present my research.